Hey guys, so I'm just going to do the part 2 today that I had intended on doing, but obviously you had assembly. Okay, so the first one of the last terms that we need to know in relation to the circle. Each tangent is perpendicular to the radius that goes to the point of contact. So you can see here we have a tangent L, and then we have 0, P is where the point of contact is between the tangent and the circle. If we join a line from the radius to that point of contact, it will always give us a 90-degree angle. So for example, if we draw another line, like the one I've just drawn here, and if I draw a line from the, let's see how this goes now, from the radius to that, so it's a little bit wobbly, but it's not the worst in the world. We can see this is going to create a 90-degree angle. So we have a 90-degree angle here and a 90-degree angle here. Okay, so that's one theorem that we need to know. And again, we don't need to prove it or anything like that. We just need to know the outcome of it. And the very last one that we need to know, theorem 21. I put down the two parts because it's this one here is the converse of the part I. So the perpendicular from the centre to a chord bisects the chord. So any sort of line that is from the centre of the circle to a chord bisects it. So it gives us two even lines either side. And I think I mentioned that today in today's class. And then finally, the perpendicular bisector of a chord passes through the centre. So the perpendicular bisector, so that basically, what they're trying to say there is that if you drop a line from the centre through the chord, it bisects the chord. Similarly, a line that bisects the chord will pass through the centre and can be considered the diameter of the circle. So I was just going to go through two questions today using this knowledge. So for the first one here, we will be able to use our theorem 20 to know that this here, x is tangent here, is tangent. If we were to extend x out the far side, that would be tangent to that corner point P. It'd be tangent to that corner point P. So if we were to extend that out this way, obviously a straighter line, it would be tangent. So that tells me that this angle here is 90 degrees. Okay, so if we have a 90-degree triangle or right angle triangle, then we can use Pythagoras' theorem to find out x, and that will give me 17 squared, so you can pause the video if you want to try this for yourself, is equal to 8 squared plus x squared. That will give me x squared is equal to, so I'm just going to put in 17 squared minus 8 squared into my calculator. I'll get 225, and then the root of 225, square root 225, will give me x is equal to 15. Okay, I'm actually just going to get into a habit now of writing that the right way around. X is equal to 15. Letters to the left, numbers to the right. Okay, when we look at the second question, we're going to obviously use that knowledge again. So we now can look at this and we can say this is a right angle triangle because that line that's extended beyond S and P is a tangent line. Now, the really good thing about this, or I suppose the extension of this, is later on when we look at trigonometry, knowing that that's a right angle triangle or knowing certain sides of it, if they asked us for any of these angles. So for example, if we knew this length and they wanted us to find out what this angle here is or this angle here, we can actually use trigonometry to find that out. Even though we only know one angle in total, we can use trigonometry, but we'll be looking at that later on. So in this case, we can say they're looking for P to X. Now, first of all, let's go ahead and find out PR, because we know that using Pythagoras again, once we know that there's a right angle triangle here, we know that 37 squared equals SP squared, which we know is 12 because they've given us that information, plus PR squared. So That's that whole length of this. So when I get PR, the length of PR squared, and that's what those lines stand for, remember. 37 squared minus 12 squared. That'll give me 1225. And if I square root both sides, I get PR is equal to the square root of 1225, which will give me 35. Now, that's not giving me x, because x is P to O. But PR is a diameter. So you can see that x is a radius. Radius. So we know that half of 35 divided by 2 will give me what x is. So 35 divided 2, which will give me 17.5. And that's equal to x. The last thing I want to cover is, I seen this question in your book, and I thought to myself, if some of you got this in an exam, which is very possible, you'd freak out. There's no need to freak out. Consider the following circle with centre O. What type of triangle is triangle A, B, and C? First of all, let us just look. When we're trying to figure out what type of triangle this is. So we know that the angle standing at the centre of the circle is twice the angle on the same arc. That will tell us that this triangle, or this angle here where the two green dots are, is 90-degree angle. So my answer there is a right angle triangle. Right angle, I'm just going to put down as RA triangle. Okay. Show that triangle ABO is equal to triangle BOC. Okay, so ABO is equal to BOC. Okay, first of all, what we can show here is that, let's look again for my radii. So I have radii here, radius here, radius here, and a radius here. Okay, a radius again is the center point, a line that goes from the center point O out to the circumference, in this case O to A, O to B, O to C. So on that note, we can say that the length, of AO equals length of AC, and it's also equal to the length of OB. And I just put a little excuse down there, a little explanation, which is radius, or radii, plural. Okay, so that's the first part. Then I can say that, so on that note then, if we look at, so we've said now that we have sides that are the same. Let us look then at our angles. So we can use, remember when we want to show that these triangles are equal, what we want to show is we want to show congruency. So we want to either show side, angle, side. We want to show angle, 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 or side, side, side. Okay. Now, on this, I would say we can show a side, angle, side would be perfect here. We could also use the two dots here that would tell us that that's a 90-degree angle, and then that's obviously a perpendicular line. But I'm gonna use side, angle, side. So side, angle, side. So what I will say is that triangle AOB, or ABO, sorry, we'll follow what they say in the question, ABO and triangle BOC are isosceles. And because we know these sides are equal, we can then say that angle, so you could number these, or I'm just going to work with angle AOB. So I'm looking at this angle here. Colour in a little bit more so you know which one I'm talking about. is equal to BOC. Again, if you're not very good at reading an angle like that, you can call that 1 and 2. So you can say angle 1 is equal to angle 2. Therefore, side angle side, which implies that, because we've just found side angle side, meaning that we have two radii and an angle in between each of those radii, or each of those radius, that will tell us that side angle side. So that tells us that they're same triangles. Okay, so therefore triangle ABO is equal to triangle BOC. Now there's a couple of other ways you could go ahead and try and find angle. You probably use side as well, and you could use, they're the two that you could definitely, all three of those you could definitely use. That one there I just think is the easiest. All right, then it says find angle ABO. So that's the next question here. So find angle ABO. So the good thing there is that on the basis that they've given you those green dots, they've told you that those angles are the exact same. So that tells me that the line BO, that's this line here, actually bisects this angle. And we know that this is a right angle triangle. So if it bisects the angle B is equal to 45 degrees. Oh, sorry, we'll put that down as what they've said. So the angle ABO is equal to 45 degrees. That's the one, ABO is the one here with the green dot. Okay. And then finally, if OB is 15 centimeters. So I'm just going to swipe off some of my drawings here for a second. So they've said now if OB is 15 centimeters, find AB. Okay, perfect. Well, we know if OB is 15 centimeters, and we've already said that OB is a radius, then we know that OA is 15 centimeters as well. So using that information, we already know that this angle here and this angle here are going to be equal, and they're equal to 45 degrees each, which gives me a total of 90, which means that this angle here is 90 degrees. And they've asked us to find AB, which is going to be our hypotenuse. So we know from Pythagoras' theorem, h squared is equal to 15 squared, so that's AO, plus BO, which is 15 squared. So h squared is equal to, and I'm just going to pop that in, 15 squared plus 15 squared, that's 450. And if I square root 450, I get 15 root 2. And I said today the best thing to do is to leave that in root form, 15 root 2. Okay, that's the value of my AB line there. So remember as well, just, I probably forgot to say it today, but just remember that when we're using Pythagoras' theorem, the hypotenuse is always, so it is the hypotenuse squared plus the sum of the other two sides to be squared. The hypotenuse is always the line that's opposite the right angle. Okay.